Hello friends, I welcome you all to this class. This is linear algebra class, and today we'll be using this theorem, Cayley-Hamilton theorem, to compute this expression given to us. We are given a square matrix A, and we want to compute negative a raised to power 17 plus 4a raised to power 16 minus 5a raised to power 15 minus 2a raised to power 3 plus 8a raised to power 2 plus 6a plus 3i using the Cayley-Hamilton theorem. We know that Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. So we are going to compute the characteristic equation of this matrix and use knowledge of Cayley-Hamilton theorem to evaluate this long expression. So the Cayley-Hamilton theorem will help us to reduce this long expression to a simpler expression that we can evaluate. So let's start the solving solution. So you compute the characteristic equation of this matrix by evaluating determinant of a minus lambda I, then equate it to 0. So this implies determinant of your A is this matrix, that's this 1 minus 1, 2, 3, then minus lambda. Lambda is a scalar, then I is the identity matrix. Since your matrix A is 2 by 2, this identity matrix must be what? 2 by 2. So we have 2 by 2 identity matrix. So determinant equated to 0. This implies determinant of this your matrix 2, 3 minus lambda multiplied by 1. Let's multiply this identity matrix by lambda. Lambda multiplied by 1 is lambda. Lambda multiplied by 0 is 0. Lambda multiplied by 0 is 0. Lambda multiplied by 1 is lambda. So determinant equated to 0. So this implies determinant of, let's subtract the two matrices. 1 minus lambda, 1 minus lambda. Negative 1 minus 0, I have negative 1. 2 minus 0, I have 2. 3 minus lambda, I have 3 minus lambda. Determinant equated to 0. This implies this is now 2 by 2. This is a 2 by 2 matrix. We want to find the determinant of it. You multiply the principal diagonal. That's this multiplied by this. 1 minus lambda multiplied by 3 minus lambda. Then you subtract the product of the other diagonal. 2 multiplied by negative 1 will give you negative 2. Then you are going to do, you'll be doing minus negative, which will be positive. So I have positive 2. Then equated to 0. This implies, let's expand. 1 multiplied by 3 is 3. 1 multiplied by negative lambda, negative lambda. Negative lambda multiplied by 3 is negative 3 lambda. Negative lambda multiplied by negative lambda, positive lambda squared, plus 2 equated to 0. This implies, so let's write the lambda with the highest power. This lambda raised to power 2. Then next one, negative lambda, negative 3 lambda is negative 4 lambda. Then our constant 3 plus 2 is what? Positive 5 equated to 0, right? This is the characteristic equation of this very matrix. Then the characteristic polynomial is the same thing as this, but this you don't equate it to 0. Characteristic polynomial, you don't equate it to 0. So you have lambda raised to power 2 minus 4 lambda plus 5. So this is the characteristic polynomial. This is the characteristic equation. Characteristic equation is a characteristic polynomial equated to 0. So this is what we have. So we are going to write, first to solve this, we are going to write this long expression in terms of what? Lambda. So we'll have two polynomials. Then we'll be using the knowledge of polynomial division to do this. So let this polynomial in terms of lambda be equal to, so we substitute lambda anywhere you see a, substitute lambda there in this long expression. So we have negative lambda raised to power 17 plus 4 lambda raised to power 16 minus 5 lambda raised to power 15 minus 2 lambda raised to power 3 plus 8 lambda raised to power 2 plus 6 lambda plus 3. So this is what we have. So we are going to use knowledge of polynomial division. We are going to use the characteristic polynomial of this matrix to divide the polynomial of this expression in terms of lambda. So we are going to do q of lambda divided by this p of lambda. So I'm using the characteristic polynomial of the matrix to divide the polynomial of this long expression here. So let's do the polynomial division. So we have something like this. So the P of lambda, we write it outside here. That's lambda raised to power 2 minus 4 lambda plus 5. Then Q of lambda, we write inside here. Negative lambda raised to power 17 plus 4 lambda raised to power 16 minus 5 lambda raised to power 15 minus 2 lambda raised to power 3 plus 8 lambda squared plus 6 lambda plus 3. So this is what we have. Let's divide. So use the lambda with the highest power here to divide the lambda with the highest power here. So positive lambda raised to power 2 divided by negative lambda raised to power 17. Use the law of indices, subtract the power. We are going to get what? Negative lambda raised to power what? 15. So use this result to multiply this P of lambda. So negative lambda raised to power 15 multiplied by positive lambda square, you have negative lambda raised to power 17. Then negative lambda raised to power 15 multiplied by negative 4 lambda will have what? Positive 4 lambda raised to power what? 16. Negative lambda raised to power 15 multiplied by positive 5, I have negative 5 lambda raised to power 15. So when you have done this, you subtract the two expressions. So you subtract so that you can get your remainder, the next remainder. So if you subtract, you subtract the lambda with the same power. So negative lambda raised to power 17 minus because you have minus again here, you have minus again here. So if you do that, this will give you 0. If you do negative lambda raised to power 17 minus negative lambda raised to power 17. So if you subtract this, you give 0, subtract this, you get 0, subtract this, you get 0. So what is now remaining is this negative 2 lambda raised to power 3 plus 8 lambda raised to power 2 plus 6 lambda, then plus 3. So this is what we have remaining, right? Then you are the highest power of lambda here is of degree 3. So it's greater than this lambda here, the highest power of lambda, which is of degree 2. So we can still divide. So lambda raised to power 2 divided by 2 lambda raised to power 3. So divide by negative 2 lambda raised to power 3, you have negative 2 lambda. So use this quantity, negative 2 lambda, to multiply your P of lambda again. Negative 2 lambda multiplied by positive lambda raised to power 2, have negative lambda raised to power 3. Negative 2 lambda multiplied by negative 4 lambda will have positive 4 lambda squared. Sorry, positive 8 lambda squared. Positive 8 lambda squared. So negative 2 lambda multiplied by positive 5 will have what? Negative 10 lambda. So this is what we are going to have. We are going to have negative 10 lambda. So if you subtract the expression, so let's subtract the expression. This quantity, okay, this is supposed to be, there's a mistake here. When we did negative 2 lambda multiplied by lambda raised to power 2, we have negative 2 lambda raised to power 3. Yes. Then if you subtract this quantity minus this quantity, you subtract lambda with the same power. If you subtract this, you get 0. Subtract this, you get 0. Then 6 lambda minus 10 lambda, you are going to get positive 16 lambda, then plus 3. So this is what you are going to get, positive 16 lambda plus 3. So if you continue so with this, the power of lambda here is 1 of degree 1. The highest power of lambda here is of degree 2. So degree 1 is less than degree 2. So this quantity is now our remainder, right? So this Q of lambda will be reduced to this remainder. Q of lambda will be equal to this polynomial. What's the quantity we got here? we got negative 15 minus 2 lambda, then multiply by the divisor, that's p of lambda, plus the remainder 16 lambda plus 3. So this is what we have. So Q of A, let's substitute our matrix A for lambda here. Q of A will be equal to, so if you come here, negative A raised to power 15 minus 2A, then multiply by P of A, then plus 16A plus 3. So by Cayley-Hamilton theorem, this matrix A will satisfy this characteristic equation, right? So, but P of A will be equal to what? 0. So this implies that our Q of A will be equal to this quantity 0 multiplied by this quantity. So this will vanish, remaining 16A plus 3. So this is what we are going to have remaining. So this long expression has been reduced to what? This quantity. Simply, it's just this long expression. To reduce this after the division, the remainder is what? 16 lambda plus 3. So you substitute A for lambda in the remainder. That will give you this long expression, the Q of A. So Q of A, now all this long expression is something as 16A plus 3 is the equivalent of it. So this will be equal to 16. What is your A? 1, negative 1, 2, 3 plus, this 3 will not be 3, it will be 3i. Sorry, because we can't be adding a constant and a matrix. So you multiply the constant by identity matrix. So I have 3i. So you'll be having identity matrix will be 2 by 2 because our matrix A is 2 by 2. So this is what we have. So 16 multiplied by 1 is 16. 16 multiplied by negative 1 is negative 16. 16 multiplied by 2 is 32. 16 multiplied by 3 is 48. Then plus 3 multiplied by 1 is 3. 3 multiplied by 0, 0. 3 multiplied by 0, 0. Sorry, we have 1 here. 3 multiplied by 1 is 3. Right? So this is what we got. So let's add the expression. This implies that our Q of A will be equal to, if you add 16 plus 3, we are going to get what? 19. Negative 16 plus 0, negative 16. 32 plus 0, we have 32. 48 plus 3, we are going to have 51. So this is the quantity we got. So thank you so much for being part of this class. See you in our next class.